Well, hey everyone. I am actually kind of trying something out here. And as I can say, there's a little echo and it's making me crazy. But I am actually been MIA for a month because I really been working on something like a little example over at TikTok. And what I've been doing is I've been taking some examples and works and putting it live and to see if I can get more followers, right? Boom. Month later, I have over 2,000 new followers. I think I want to kind of do this. I think I want to see what I can do to expand it. So I'm coming live here just to kind of show you an example of like one thing that one of my kids are really struggling with. So since now I know you guys can hear me, I'm going to take this earbud out so I don't have that echo. And then I can just continue talking like a regular human being. All right. So right now, a lot of my students are starting to get into exponential and logarithmic. And some of them were starting to get a little confused by it. So I'm going to actually walk you guys through step by step how to do it. If you like it, awesome. Take it, own it, move it. But if you don't, why not? Because this is how you're supposed to do it. All right. So let's us zoom in. We're looking at exponential to logarithmic, okay, or vice versa. We're going to actually work on this general forms and kind of go back and forth. But as you can see with exponential, it's your b, which is your base, raised to your x is equal to an a. All right, so you have your base, you have your exponent, and then you have what I like to call the result. Now the same thing is happening over here. If I have 2 raised to the x is equal to 8, that means my 2 is my base, my x is my exponent, and the 8 is the result. So for me to go to exponential to its inverse, which is logarithmic, I have to make a couple of changes. One thing that is definitely different is one, we don't have an exponent, and two, we got this word called log. All right. I don't know if you remember Ren and Stimpy when there was a song about log. Every time I see the word log, I think of that song. Maybe it's just me. Maybe it's me losing my mind. Right. So now we got a log, but notice the B, the base. So the base is now your base of its log, which is down as a subscript. Okay. Then our result is adjacent to it, but the exponent is outside the equal sign. All right. So this is what's happening. We're going to use that same 2x, okay, equals 8. 2 raised to the x is equal to 8. So we have our base of 2. Now it's down here. Then we had the result, which was 8. Now it's over here. And it equals our exponent, which is outside the equal sign. All right. So with that, think of it this way. For me, I try to think of it like sports. So when you're about to hit, okay, you're in the line of scrimmage, the ball has been hiked. When you go to hit someone, you never do a line drive. If you try to do a line drive, you're going to die, all right? Because you're going to break your neck and that's the end of it. Anytime you see people hitting, they hit upwards, right? They go past the line of scrimmage and they hit drive upwards. Same thing is going to happen here. For me to go from a log to an exponential, the equal sign is my line of scrimmage. So I'm taking my base and I'm going against x, and I'm going to hit and drive him or her, because we're going to try to get some female football in there, drive them up. Okay, drive them up and away. All right. So you hit them up and then you drive them out. So that base is now your denominator, or basically your 2. Your exponent is your x. And then what is left behind, if you want to stick it this way, what's left behind is your result. So for us, we don't read from left to right. I mean, we read from left to right. I'm like really tired today. We don't read from right to left. So if you want to switch these around, you can. So now you have your 2 raised to your x is equal to 8. So that's how you go from a log to an exponential. For you to go from an exponential to a log, first we're going to write our log. And what goes here in this spot is whatever your base is. And our base is 2. Now, if you don't see anything there, it's assumed that the base is a 10. That's why I wrote this here. So if you say log 10 means just simply log. All right. So now you have your base and it's going to have your result right next to it. So our result is 8. Then we have our equals, and it's going to equal what our exponent is. In this case, it's going to be an x. All right. So that's basically how you go from a exponential to a log, and how you go from a log to an exponential. All right. So there may be some delays, but we're going to see if we can get a couple examples in here. All right. So I kind of like to put into the step to go from a log to an exponential. Okay. So drive up past the line of scrimmage. Okay. So this is easy for me to remember because I'm thinking of football, right? But maybe for you, your steps might be a little bit different. You might be like, take the small 2 and drive it up to the x, whatever it is. I like to kind of put it right here as a quick reminder. So when I'm looking at my next example, so let's say I have 10 squared is equal to 100. So since I have this squared, that's telling me already that's exponential. So I want to go from exponential to logarithmic. And the only way that I can do that is, one, I'm going to write the word log. And remember, my base is going to go down here. Remember how we have it here? Here's my base. So my base is going to be the subscript next to the log. My base is 10. Then you're going to have your result, which comes next. In our case, the result is going to be 100. And it's going to equal your exponent. And my exponent is 2. Now, I know we're just starting out, but anytime you see a log with a base of 10, you could just simply write the word log, because the base of 10 is always understood to be a part of the log. All right. So you don't have to write log base of 10. It's always assumed that it's there. So that's how you go from an exponential to a log. So now, let's say we have, let's try this one. Let's try like 4 raised to the negative 1 is equal to 0.25. Okay, or 25 hundredths. So for me to go from the exponential, because I have an exponent, that's how I know it's exponential. So for me to go from an exponential to a log, I'm going to write the word log. Now I'm going to my base. My base is 4. Then I have my result. My result is 25 hundredths. And it's going to equal my exponent, which is negative 1. Okay? So these are going to be your results. That's how you go from exponential to log. You follow that same pattern that we have labeled here. Here's your base, here's your result, here's your exponent. All right? So moving on from exponential to log, let's kind of look at it from log to exponential. So if we have, let's see, log base, here we go. What we're going to do is keep it simple. So we have log of 2, 32, is equal to 5. So we want to go from a log. So I know this time it's not a log base 10 because there's a 2 there. So I want to go from a log to an exponential. So I always start with the base. So as you recall, from up here, we have our base. So I want to start with my base. So when I go here, I have 2 as my base, and my exponent is going to be outside. That's going to be my 5. Remember, I'm going to drive past the line of scrimmage. So 2 is my base, 5 is my exponent, and it's going to equal 32, which is the result. So that's how you go from a log to an exponential, right? So if I do it once more, I'll have my log base 6, 216 is equal to 3. So this time I have my base, which is 6, past the line of scrimmage, so that means that 3 is my exponent, and it's going to equal my result, which is 216. Okay. Now, that's dealing with what we like to say common log. Like if you just see the word log, that's your common log. But there's another one that I have listed here. We have ln, and I know you've probably seen in your calculator and you're like, what is an ln? ln is your natural log. That one doesn't have a base of 10. That has a base of e, okay? Believe it or not, e is a number. I know, I just blew your mind, right? Because if you ever notice, most of the time in your math books, when they use variables, they never use 2 letters. They hardly ever use an E, and they hardly ever use the letter I because they represent numbers, right? So if I did the natural log, okay, if I ever have ln, say like the natural log, and I have like ln and it has an e to the first power. I know, I'm just working here. If you ever get something like this, ln has the same base of e. This result has a base of e. Anytime you have 2 of the same bases, they basically cancel each other out. And then what's left is your 1. Okay? So anytime you see something with the base of E, like if I wanted to know, I don't know, let's say if I wanted to know ln and let's say, which will give me let's say a -1. Probably not. So ln, let's switch it up. So if I say ln of x is equal to -1. There we go. There we are. All right. So if I say ln x is equal to -1, and I want to figure out what is my result, I need to go from a natural log to a base of e. So you don't see anything, but it's always assumed that there is an e there. So I need to change it from a logarithmic to an exponential. So I have my e raised to the -1, because remember that line of scrimmage thing, equals my x. So if you know anything about negative exponents, you will always, and I do mean always, have to flip it because you don't want to leave your answers with a negative exponent. So this is almost like the same as saying e is over 1, but I got to do the opposite. So that means my e to the first power is now dropped down into the denominator. So this is why when you have a negative exponent, majority of times it goes to a fraction. Okay. All right. So you have your logs, you have your exponentials. The way you go from an exponential to a log and the way you go from a log to an exponential, it's all relative depending on what you're looking at. So my suggestion, it's going to be this piece up here. So 2 raised to the x is equal to 8. And then you have your base of 2's, you have your exponents, and you have your result. All right. Now, one other thing that a lot of my students were having major trouble with, I'm not sure, but we're going to flip to the other side. And the other thing that a lot of people generally had problems was finding the inverse. So I know for us math people, we're like, ooh, I love finding the inverse. So we want to see what is the opposite of our equation. So let's say, for instance, we have y is equal to log base 6 of x squared. So the major way that you can do this, when they say inverse, we need the opposite. So that means we're actually going to be switching our x and our y's. So instead of y equals, it's going to be x equals. We still have that log, base 6, but instead of an x, we're going to have a y squared. And we're going to solve this equation for y, okay? So we want to find what's called the inverse. So in order for us to change that equation, we need to isolate our variable. So a lot of people will say, all right, well, where do I start? Like, how do I get y by itself? Do I go ahead and square root? No, because you have this log base 6. So some people will say, all right, well, can I go and say 6 raised to the x to get it out of that log function is equal to y squared? And I'm like, ooh, there we go. All right. So we have our 6, and it looks weird because it's on the other side. So all we did was we move our 6. There's my line of scrimmage. That means we put that x as an exponent. So now we want to get y by itself. So in order for us to get y by itself, we want to do the square root of both sides. So now that means we have the square root of 6x is equal to y. And is my y by itself? And the reason why, because squares and square roots, they cancel each other out. They're inverses of each other. So if that is the case, we basically found the inverse of that equation. All right. So I just want to see. I want to see how things are. I know usually on TikTok is a lot more interactive, but I just wanted to kind of see how my setup goes and how's it look. And I'm like, I actually kind of like how it looks. So if you are still here and you're kind of looking at some of my stuff, and if you like the setup of my book here, I designed this book, right? So I actually put together a math notebook. So we have two different versions of it, or actually three covers, but there are two versions. So this one is the most popular one. It's starting to sell like hotcakes, which is awesome. All right. So it gives you a section for you to write your formulas. It gives you a section to write out your steps, as well gives you some room to work out some of the problems. Now, on the very top, obviously, you have what the topic is. You can put, oh, this is day one of this lesson. And as well as you can kind of do like a mood tracker. Like, how are you feeling before the lesson, during the lesson, and after the lesson? So this would be great for like homeschool parents, classroom parents. It'll be great for all. Now, say that you're not very strong with your multiplication table. That's fine. I got resources out ZY is zoo. All right. So if you take a look, I have a factor sheet that lists out all the factors from 1 all the way up to 200. Because I basically had a lot of my, you know, seventh graders all the way up to adults in mind. So usually a lot of the notebooks are really geared towards elementary school kids, but we don't really have anything, especially math wise, for those advanced students. Now, if you forgot certain words and certain terminology, okay, so we're looking at the most popular words and phrases that are used in most word problems are listed here. If you forgot the rules of your integers, I have for addition, I have for subtraction and multiplication with examples, as well as we have like a couple of things with my geometry folks with the properties of transformation, the translation, reflection, and rotation and dilation. Okay, we have the properties of quadrilaterals. I know this used to make me crazy when I was a student. So, like trying to keep up with, all right, are they bisecting? Are the diagonals bisecting or are they perpendicular? I have no idea. Then a lot of people are starting to get into this Pythagorean theorem, and then also your sine, cosine, and tangent, the SOHCAHTOA. And some of our advanced students are starting to get in with the identities, especially for your pre-calc kids. And I know a lot of people in geometry are starting to look at volume, and they're also starting to look at surface area of those three-dimensional figures. So those formulas are in here, as well as looking how to find the area of the sector and also arc length. In addition to this, the one famous one that a lot of people are really touching upon is the unit circle. So I have a copy of the unit circle with its breakdown at the very end. Okay, so with all this information, if you need a brain break, we definitely got some tools and some puzzles to kind of help you with that brain break in order for you to sketch some things out. All right. So if you are interested and you're like, ooh, Audrey, I love that math notebook. Where can I get it? You can get it on Amazon. All right. So if you just go to my profile and you go to my website, on my website, I do have a section that says Ultimate Math Notebook. If you click on that, it will take you directly to the page on Amazon for you to purchase. And in addition to, this is again 7th through adults, but I do have one for our youngsters, for our 4th through 6th graders. Okay. Same format, but I made it a little bit bigger because I want them to practice putting their numbers in number tiles so we can learn to keep things organized. They still have their formula section, they still have their step section. It's a little smaller book for a little smaller hands. And also, it has a resource pages, of course. They also have a factor sheet from 1 to 200. Then they also have something with dealing with fractions. What is the definition of a fraction? What are the parts of a fraction? Also looking at the examples of what's it look like in its rare form. What would it look like as a circle graph? Then we had a couple others. Then we talked about the percents to decimals and give them examples of what it looks like. So same with the decimals of fractions, and let's not forget about fraction to percent. Then we have the fraction operation, okay? So what does it look like with addition? What does it look like with subtraction? What does it look like with multiplication and division, right? As well as place values. Notice everything is color coded, okay? The reason why there's some coloring, it really attracts the eye and it helps the students to remember a little bit more, as well as the decimal points. And it gives you an example of not only how to write it, but also how to read it. Then on top of that, decimal operations. So how to add, how to subtract, how to multiply, and to divide with decimals. And then we have our rounding, long division, because once the calculator came into the classroom, a lot of people do not teach long division. Here's another one, the conversion chart. I'm actually thinking about adding that to my latest book because a lot of people are doing conversions, especially those adults that are thinking about going to nursing school, right? So if they're thinking about going to nursing school, they do a lot of the conversions and even with the setups. And order of operations, this is huge not only in the US but also internationally. It's the same concept, but it's also presented differently. So I'd like to show that. Then we have the properties of exponents. That's also in my other book. And then we have area and perimeter, things that are very useful in that 4th through 6th grade life, as well as the reference page as I had before. But I really want to focus on the surface area of a cube and the surface area of a rectangular prism, because those are used quite often for that age group. Then same with the reference pages here. Thanks, Beth. Same with the reference pages here. And also, I gave you an example of a writing and solving an equation, how to break that down, as well as still have the rules of integers with them. And also different brain breaks, just to give them some opportunities just to do some mindless coloring, just to help with the refocus. And if they're into pixel art, give them a section for them to do pixel art. All right, as well as answer key, which I don't want you to show. Okay, so there are 2 different types. You have 4th through 6, you have 7th through adults. Still 100 pages, 100 of these note pages. This is for the younger ones, 4th through 6. Then this is for the older ones with the dot, and you can do a lot of the grinning. So I did a presentation on the Pythagorean theorem. Notice I can cut and paste and give it some room. I can, if I wanted to use pen, my suggestion would be erasable pen. Okay, how would I do those functions? What does it look like? Also, how does it look like on my grid side? So no longer that you have to go finding grid paper. Like you got everything all in one go. So if I show you my other book, which I'm thinking about auctioning off, okay, so this is how it looks. Okay, dividing the polynomials. And I like to do the dots because I can graph so much cleaner. Okay, I don't know what it is. Actually, I do. And I can actually graph it so much cleaner because I have like points everywhere. And then plus I can write out the formulas that I want, the steps that I want, as well as if I want to do the grid side, You can also do on the grid side. So the grid side, you can use it for extra practice. If you want, if a teacher says, hey, I really want you to keep this paper in your notebook, you can have them put that paper taped into their notebook and then use the other side to summarize what's on that paper. That's one way of really emphasizing the learning. So now everything is all in one. Okay. So no more. I, I have to be honest. The reason why I did this because a lot of my students that I tutored, their notes was like, ah, and it was making me seasick. It was just crazy. Right. It was just everywhere. And there'll be like packets, and there's a packet over here, and there's a packet over there, and they're flipping through all the packets, and all of a sudden they have no idea what they're looking for. But by putting little compartments and showing them, here's rate of change, showing them the formula of rate of change. Also, here's the steps of how to do the rate of change. And then also having your notes, being able to break it down, it's just a lot easier and a lot simpler to digest. All right. So that is basically what I wanted to do. I just really wanted to just come on here. One, give a little bit of practice. Two, show you my books. And three, see if this is another option for me to basically share my wares with everyone. Let's see. I think somebody's there. Hey, Robert. Okay. I was just working on this with a couple of my counselors. It's funny what pops up later on. I know, right? Just kind of working on like that. So I know everyone keeps saying these things. So that's all I really want to do. Hopefully you guys are having an amazing day and we'll be able to break down even further how to do all these great and possible things so we can actually be able to help our kids go from point A to point B a lot smoother. All right. So I will talk with you guys later. I'm actually going to shut down. And if you do want to, do not forget to go to the link in my bio. You can type in click on my website, which will take you directly to the page that says the Ultimate Math Notebook if you want to make your purchase today.